In this video, I'll find the stable distribution for the transition matrix T. Let's suppose that there's some Markov process that has this transition matrix, and we want to know if it reaches a stable distribution. The first thing that we need to check is whether or not the matrix is regular. This matrix is regular because it has all positive entries. There are no zeros in this matrix. So we're guaranteed that it has a stable distribution. To find the stable distribution, I want to think about what it means that a distribution is stable. And what it means is that if I take the matrix and I multiply the distribution, in this case I don't know what the numbers are and I'm going to call it x, y, z. So when I multiply t times the distribution, I get that exact same distribution back again. Now this translates to a system of equations. Let me write that system right below it. I'm going to actually do the multiplication on the left. I get 0.3x plus 0.1y plus 0.2z is equal to x. That's in the top position over here. 0.4x plus 0.8y plus 0.6z is equal to y, and 0.3x plus 0.1y plus 0.2z is equal to z. We also want to have the numbers x, y, and z add up to 1 because these are going to be either proportion, percents, or probabilities. So they need to add up to 1. I have to adjust my system of equations so that it has only constants on the right-hand side. So in my first equation, I'll subtract x from both sides. I get negative 0.7x plus 0.1y plus 0.2z equals 0. In my second equation, I'll subtract y from both sides. 0.4x minus 0.2y plus 0.6z equals 0. The third equation, I subtract z from both sides. 0.3x plus 0.1y, and in the third column I have negative 0.8z and 0 on the right, and I have x plus y plus z equals 1. I need to solve this system of equations, and so I'll go ahead into MATLAB and type in the augmented matrix for that system. Here in MATLAB, I've typed the augmented matrix for the system. I'm then going to use the RREF command and reduce that matrix, and I see there is a solution and it's in the last column, and x is equal to 0.1429, y is equal to 0.7143, and z is equal to 0.1429. That is going to be my stable distribution. To check that this is a stable distribution, I first extract the last column of my matrix and call it x. I take answer of rows 1 through 3 and column 4, and there I have my what I'm hoping is my stable distribution. To check it, I'm going to type in the matrix T, the matrix that I started with, and then I will multiply T times x and show that I get the exact same distribution back again. Once that happens, it will happen for the rest of the chain. So here I have the stable distribution for my matrix T.